Hello and welcome to the CompTIA Cybersecurity Analyst CySA Plus Certification Study Guide. In this video, we will discuss Chapter 8.4, More Managing Vulnerabilities. Please like, subscribe, and leave a comment. Threat Modeling. Consider the following principles about a cyber attack. Defenders cannot always assume the most likely course of action by the threat actor. Defenders must take into account all unlikely events and be prepared for them. Given the same tool, different adversaries may have different capabilities to use it. Only the attacker knows when an attack starts and ends. Principles in the physical world may not always translate into the cyber world. Some attacks can be from an individual, while others can be from a large group. There is a wide spectrum of the adversary's abilities, capabilities, and goals. These principles illustrate the difficulty in not only anticipating attacks, but also being able to defend against them. One method that has gained increasing popularity in cybersecurity defense is threat modeling. What was once a theoretically interesting concept, threat modeling has now moved into a cybersecurity standard of significant value to enterprises. Threat modeling involves defining the concept, knowing the components of the modeling process, and understanding different threat modeling methodologies. Definition of threat modeling. At its core, threat modeling is a proactive strategy for evaluating risks. It involves identifying potential threats and developing tests to detect and respond to those threats. Threat modeling has several advantages. Address new threats. When performed routinely, threat modeling can also help security teams ensure that protections are in line with evolving threats. Become more proactive. Threat modeling enables enterprises to perform a proactive cybersecurity threat assessment. Security teams can use threat modeling insights to evaluate risks, develop a deeper level of understanding. Threat modeling helps an enterprise understand how threats may impact systems, how to better classify threats, and how and why to apply appropriate countermeasures. Prioritize threats and mitigation. Security teams can use threat modeling to prioritize threats to ensure that resources and attention are distributed effectively for mitigation. Because it is a model, the prioritization can be applied during planning, design, and implementation of cybersecurity to ensure that the solutions are effective. Components of a threat modeling process. There are several components that must be considered when performing threat modeling. Adversary capability is assessing the attacker's intent, ability, capability, skills, tenacity, and available resources. Nation-state actors have a higher adversary capability than unintentional insiders. Total attack surface is the sum total of the number of different attack points. Typically, larger enterprises have a higher total attack surface. Attack vector is the method used to compromise a vulnerability. Examples include weak authentication credentials, misconfigurations, malware, and poorly implemented cryptography. Impact is the effect or influence of the attack on the enterprise. Includes reputational damage, fines by government or regulatory agencies, and loss of customers. Likelihood is the probability of an attack occurring and being successful. This can range from low to very high. Threat modeling methodologies. An enterprise can design its own threat modeling process that encompasses the necessary components. One of the first threat modeling methodologies that an enterprise could create had the basic goals of better understanding who the attackers are, why they attack, and what types of attacks might occur. This early threat modeling often built scenarios of the types of threats that assets can face by the construction of an attack tree, which is a visual image of the attacks that may occur against an asset. Drawn as an inverted tree structure, an attack tree displays the goal of the attack, the types of attacks that may occur, and the techniques used in the attacks. The concept of attack trees was developed by Counterpane Internet Security. Partial attack tree. Figure 8-6 shows a partial attack tree for an attacker who is attempting to log into a restricted account. The attacker may attempt to learn the password, level 2, by looking for one that is written down and stored under a mousepad in an office, level 3. They could also try to get the password from the user, level 3, by installing a keylogger on the computer or by shoulder surfing, level 4. An alternative approach may be to steal the password digest file to use offline cracking, level 2. Attack trees help list the types of attacks that can occur and trace how and from where they may originate. Although originally helpful, Attack trees were too simplistic to be of real value to an enterprise. Today, there are different threat modeling methodologies that can be used. Several of these have a specific focus. The most popular modeling methodologies, with the focus in parenthesis, are Octave, Practice. The Operationally Critical Threat, Asset, and Vulnerability Evaluation, Octave methodology, was one of the first created specifically for cybersecurity threat modeling. Octave is designed for assessing non-technical organizational risks that may result from compromised data. Using Octave, an organization's information assets are identified, and the datasets they contain are assigned attributes based on the type of data stored. Drawbacks are the documentation can become very large and it lacks scalability as more users and applications are added. Trike, Acceptable Risk. Trike is an open-source threat modeling process that is designed to satisfy the security auditing process from a cyber risk management perspective. The foundation of Trike is a requirements model that ensures the assigned level of risk for each asset is acceptable to the various stakeholders. Once the requirements model is in place, a data flow diagram, DFD, is then developed to illustrate how data moves through the system and the actions users can perform within it. However, Trike requires an overall view of the entire system before conducting an attack surface analysis. This can be difficult to scale to larger systems. PASTA, Attacker. The process for attack simulation and threat analysis, PASTA, is a relatively new threat modeling methodology. It is a 7-step process for risk analysis that does not depend on which platform is being used. The goal of PASTA is to align business objectives with technical requirements while taking into account business impact analysis and compliance requirements. PASTA combines an attacker-centric perspective on potential threats with risk and impact analysis. It, however, requires a significant investment in training. STRIDE, Developer. STRIDE stands for spoofing, tampering, repudiation, information message disclosure, denial of service, and elevation of privilege. The goal of STRIDE is to ensure that an application meets the security properties of confidentiality, integrity, and availability, CIA, along with authorization, authentication, and non-repudiation. Once the security subject matter experts construct the DFD threat model, system engineers or other subject matter experts check the application against the STRIDE threat model classification scheme. STRIDE is most useful when creating a risk-aware corporate culture and is very customizable to an organization's specific security objectives and risk environment. VAST Enterprise. The visual, agile, and simple threat VAST modeling methodology was developed to address the weaknesses and implementation challenges in the other threat modeling methodologies. The founding principle is that threat modeling must scale across the infrastructure and entire application development, DevOps library, and provide actionable, accurate, and consistent outputs for developers, security teams, and senior executives. A fundamental difference of VAST is its practical approach. Recognizing the security concerns of development teams are distinct from those of an infrastructure team, this methodology calls for 2 types of threat models. When choosing a threat modeling methodology, there are 3 primary considerations. First, the outputs of the model should be considered. While all methodologies may be capable of identifying potential threats, the number and type of threats identified will vary significantly, as will their quality, consistency, and value. Another consideration should be scalability. At the enterprise level, the ability to scale across hundreds or even thousands of threat models must be taken into consideration. The final consideration is the overall goal. Some enterprises are looking for a model that will generate relevant financial and productivity reports for executive financial reporting. Other enterprises may have the goal of reducing the organization's overall threat profile, attack surface, and risk portfolio. Governance can also play a role in addressing vulnerabilities. Governance requires knowing what it is, its bodies, and the mechanisms for applying it. What is governance? Governance refers to the structures, systems, and practices an organization has in place to assign, oversee, and report. These 3 activities include assign. Governance is involved in assigning decision-making responsibilities, defining how decisions are to be made, and establishing the organization's strategic direction. Oversee. A key element of governance is overseeing the delivery of its services, the implementation of its policies, plans, programs, and projects, and the monitoring and mitigation of risks. Report. Governance involves reporting on performance toward achieving intended results and then using that performance information to drive ongoing improvements and corrective actions, monitoring and revising. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. We will see you on the next one.